Alright, hey everyone, this is Geothermal. I am recording myself doing Codeforces round 565 because I am very bored today. Starts in about 30 seconds. I'm using two monitors for this, so I'm going to hopefully remember to switch between them as necessary. So here you should be able to see my ID and here back to Codeforces. Hopefully that worked. Alright, looks like it's working fine. Guess I should get my template ready. And here we go. Okay, this is really laggy, so I'm going to go on M2. Oh, here we are. Alright, we can... Okay, we need to try and get one from a number, answering Q queries. We have long, we can replace n with 2n over 3, 4n over 5 for n over 2. Seems like greedy might work. Just divide by 2 if we can. Obviously, if it has any prime factors other than 2, 3, 5, then it's not going to work. Oh yeah, wait, we're just going to always have to... yeah, there's only one way to do it, actually, so yeah, this should be easy. Alright, and let's get coding. Okay, for test case Q. Alright, and then we're gonna need to break if it's impossible in here, so I'm just gonna add this. Oh. Alright, and then if none of these work, then it's impossible, so we have to go to done. Alright, and let's test this real quick. No sense in getting a wrong answer on the first problem. 0, 3... Okay, that is not good. So let's see, so for 10 we should have to divide... Okay, let me see. Oh, I forgot to increment the answers here, duh, okay. Well, that's why we test. And let's just run this again. 0, 4, 6, 6, negative 1, 6, 72. Awesome. Alright, so I think we can submit this. And I'll switch back to the Codeforces screen, and then I guess I should pull up the rest of the problems. Okay, let's see. One moment. I'm gonna go ahead and save this. I'm just gonna assume that this got accepted because it's really not a particularly complex problem. And let's read the second problem. All right. Okay. So we want to. Okay. This is easy. We just have to take the number that's divisible by 3, or that are divisible by 3 plus the minimum of 1 or 2 mod 3. Since I want to go fast, I am not going to be explaining my reasoning in particularly significant levels of detail. Oh shoot, I forgot to switch to C line, sorry about that. Well, already just about finished programming this anyway. It's actually easier than A to write, I think. Okay, how am I getting 5 for the second query? Oh wait, oh actually, yeah, this is a little more complicated because if we have a bunch of, yeah, so, actually here, let me try this. And then yeah, this is just accounting for the fact that we can merge 3 of the same kind to get a valid possibility. Oh yeah, and I need to actually initialize these to... Hoping that this doesn't, that I won't make this many mistakes on the actual hard problems. Alright, and switching back to Codeforces, submit this. Accepted on A, unsurprisingly. I'd have been very worried if that did not work. And I'm just going to save B real quick. And on to C. Okay, we have an array consisting only of 4, 8, 15, 16, 23, 42. And what? Okay, this doesn't make sense. First the sequences first, second. K over 6 subs. Yeah, what does this mean? Oh, now I see. So we have to be able to yeah, okay. So I guess it's just okay, yeah, so this is, I think I know what to do here. So we basically need to just keep track of how many subsequences we can make and subtract any elements that can't contribute to a subsequence. Into 4, 8, 15, 16, 23, 42. And then I'm just going to make this array. That's going to store how many of each type we can make using the elements we've already seen, and then for in, except we want val is 0 to equal, let's just make it 1,000,000, and then okay, and then for if val of I greater than 0 and r of I equals cur, then val of I minus minus, val of I plus 1 plus plus, and then we want to print out n minus 6 times val of 6. Val is basically storing the number of subsequences we can create that end at a certain element in the array. 0, good. And then this we should get 3, and we do. B still in, and let me switch back to Codeforces. Our B is still in the queue. Oh, there we go, it got accepted. Thank goodness. All right, so I'm going to save C, making good time. And then let's read problem D. Okay, we have an array consisting of n integers, 2 to 200,000. Ooh, looks like math. If A is a prime number, then one integer piece of AI is appended. What does this mean? Oh, the AI prime number, okay. Greatest divisor of A divide. I'm just gonna make sure that C passed, and it did, yes. Okay, this is weird. Yeah, so I guess really we can, so first of all, if A sub I is prime, then it's easy to match to P sub AI. So I guess first order of business is maybe to count the number of primes in this list, and then for the rest, if we have any numbers that are, it's a little tricky. Obviously, since the array is being shuffled, order doesn't matter, so we just have to find some way of matching it up. So I guess let's look at the examples. So obviously, since we can't have... Actually, no, that's not necessarily true. So let's see. So I guess first step, let's factor everything, and then I'm going to be doing a bit of work on my scratch paper over here. And then one thing we can note is that for any element, after we divide it by its greatest prime factor, we can. And I guess one other issue is do we need to compute the first 200,000 prime numbers? Because that's going to be a lot to work with. I guess maybe we can just say, okay, if it's a really, actually no, because if it's just a really huge prime number, then we know that's not going to be in the final. Then we know that's not going to be in the final array. So we can just delete the huge. Actually, no, this might still be a little tricky. Okay. So I guess first of all, if we have any composite numbers that don't have any composite numbers that don't have multiples in the array, we know those are going to be an A, and we can get rid of those, and then we can keep doing that. Will there ever be a time at which this becomes ambiguous? Or will that let us get rid of every composite number? All right, well, let's just say for the sake of argument that we can get rid of all the composites like that. And then I guess one thing we can note is that for the primes, we can just sort them by size. And yeah, this is going to be a mess to implement. I'm just going to make sure the E isn't really easy real quick. All right, I'm gonna work on this. Okay, so let's try and make this a little more formal. So I guess first of all, let's sort the data, process it from largest to smallest. Actually no, because we want to process the let's factor everything and let's process the composites largest to smallest and the prime smallest to largest. Yeah, so if we process the composites largest to smallest, that'll work, and then the primes smallest to largest, then okay, I think I have an idea of how to do this. It's gonna be a mess to implement, but I think I can do it. All right, so first we're just gonna pre-compute all the primes. So for I2, and then we want ones up to the square root of n, so root 200,000 is 20 times 10 to the fourth. So if we take the primes up to, which is oh no, I'm doing my math wrong. Wait, no, this is right. So if we take yeah, so if we take the primes up to 500, that'll be enough. If I mod and I'm gonna make a set of Oh wait, no, we don't want to make a set of these yet. But I do want to make an is prime array. I'm just gonna change the mx to be high enough. Okay, so no, we're not gonna have, well, I'm just gonna set is prime of 1 to be true, just because it doesn't really matter here. If I percent primes of j equals 0, and then actually no, I'm not gonna. It's not really any good reason to break. Is prime of I equals good if good primes dot p and push back I. Okay, and then now we just do the same thing except for the large primes. And I think if we just maintain the is prime array, that'll be good enough. I 500 mx bool. And then actually we can just do the exact same thing, except we're not going to be adding them to primes. We're just going to be maintaining the is prime array. Alright. So now let's actually process the data. So I am recording. Yeah, I'm recording the C line. Good. Okay. Oh wait. Okay. Yeah. So for I 2 times n, if cur greater than or equal to mx or cur or is prime cur. Actually, we need to do a multi-set, don't we? And I'm using a set here because that'll support efficient removal when we need it, which is important here. I'm hoping. Do we need to? Let me look this up real quick. Okay, cool. The iterators keep their validity. That's going to be important here. All right, awesome. So, okay, cool. So let's start with the composites. For auto it equals data c dot end. Oh, oops, I need to actually call the method. And then I guess I'll need to do the if, actually I should do this with the do while. Okay, so equals star it, and then for if cur percent I equals 0, we know it's going to be divisible by a small prime, so and then I'm just going to have found over here. Oh, because I need to do primes of I, not I. Okay, so we found the result here. this is what we should be looking for, and then if data C. Okay, and I'm just gonna, and then we can push back cur into the answer, and then if dot find. Let me just make sure I'm familiar enough with multi-set find. If data C dot find res is not equal to data C dot end, then data C dot erase data C dot find and then otherwise it's going to be prime. Basically what we're doing here is the res is the element, the res is the greatest divisor or the greatest proper divisor of cur, and so we know that that's not an array A, so we can remove it. And then all right, cool. And so now we have the remaining primes, and so and I guess actually this is why we need large primes, so I'm just gonna add that real quick. Okay. All right, this one we can just do with the standard for loop. Equals data p dot begin plus. Oh wait, no, we need to do id2 not equal to data p dot end plus plus. All right, so and actually I'm just getting this actually is how I should do it. For I sc find var primes dot pb primes of I. Yeah, that makes more sense. This problem's taking me way too long, by the way. Okay, so and stop push back cur, and then if cur less than large primes, like oh, actually hold on. So if cur greater than 200,000 break, because we're done. We can't have any prime. Obviously we're not going to have any too large primes in the array. If cur is less than size of large primes, then data p dot erase find data p dot find large primes of and actually we'll need cur -1 because we're doing one indexing here. Okay, and then I think now we can just do for I and cout and then we can just print end line, and technically this is finished, but I suspect that we're going to have some bugs in here. Okay, well that worked. Let's check the next sample. Oh, whoops, I accidentally stuck a slash in there. Okay, well we're still getting a seg fault, so that's no good. Alright, so let's debug this. So first of all, let's just check. Alright, cool, both of those are prime as they should be. And then we should have, we should be basically ignoring, okay, no, we're getting an issue with this composite part. I guess here, let's perhaps, let's see if the size of data c equals 0 dot begin. I think that might be the issue. Let me just Google this and make sure what happens if Oh no, because if it's empty, it should be the same as multiset.begin. Oh yeah, no, this is the problem. Okay, yeah, I should be doing a while, not a do while. Okay. Yeah, because if it's already dated, or if it's already equal to the begin, then meaning if there are no composites, that is not something we want. All right, cool. And I'm kind of suspicious of this, so kind of want to just write one more test case. All right, well, this is working. I'm gonna submit it real quick, and we're going to cross our fingers. I was pretty confident in the previous three solutions, but this one I am not really convinced is going to pass. So, all right, test 4. Let's read E while we're at it. We have a vertex. We need to choose at less than half the vertices, such that each unchosen vertex is adjacent to at least one of the chosen vertices. Okay, and we need an O-of-N algorithm. That seems like that should not be that hard. Huh, this is taking a while, actually, although that happens sometimes. Okay, let's see. I guess, first of all, isn't it going to just be possible to do this on a tree? Yeah, we can just, yeah, okay, we can just take the spanning tree, root it, and then take every other level. Or we can just like do a DFS tree and well, can we? Actually, we may need to do a BFS tree. That may be smarter here. Yeah, I'll do BFS. I like BFS better anyway. So I'm going to assume that D is going to pass. Oh, shoot, TLE. That's weird. Okay. Well, let's fix this first then. And let's figure out where this is TLEing. Okay, so this part up here should be fine. I guess it might be like the multi-set time complexity. Multi-set find is logarithmic and erase. Okay, let's see. Multi-set erase is it's okay, constant time, that should be fine. Okay, and then give me 1 second. I'm gonna mute my mic for a moment. Let's see. All right, sorry about that. Let's figure this out now. So, okay, so this should go up to 200,000, and there will be like about 100 primes in there, so that should be fine. If current is prime, yeah, this should be fine. Cur equals stuff for I SC of primes. I almost wonder if there's somehow some issue with our iterator that's causing this to be an infinite loop, although I guess probably not, because there's probably not because it's probably not because it took so long on the earlier cases too. And push back cur. I guess actually here, why don't we here, I'm just gonna do a dumb case. If I cur equals 2. Else if I'm just gonna do n equals 200,000 here. That is the max n, right? Yeah, okay. Cur equals 3, else cur equals 4. And let's just see how long this takes if we set n to 200,000. And this should give us a bunch of choosing. Okay, so this was fine. A little marginal, but overall fine. Okay, shoot, this is a pain. Kind of tempted to just go on to E real quick since we have a, and I think that's what I'm going to do because E is going to be pretty easy to implement. And we'll come back to this. Oh, shoot, I just realized I've been on the Codeforces screen all this time, my bad. I haven't really been doing much, just trying to figure out what's wrong with D. Oh wait, hold on, first I have to do T. Or test case T, and then read in N and M, vector VI graph with size N, and then for IM into A, B, C into A, and B, A minus minus B minus minus, graph of A dot pushback B, graph of B dot pushback A, and then now we're essentially just doing, and then now we're essentially just going to do BFS. Actually, we're going to do even depth because the first depth is going to be 0. And depth of n, depth of 0 equals 0, even depth dot. Actually, no. Let's just, okay. And then, first, for I and depth of I equals -1. Okay, and then now q of int q dot insert is insert, right? No, it's push. While q is not empty, cur equals q dot front. If depth of cur %2 is 0, even depth dot pushback cur, and then for I size of graph cur, and next equals graph of cur of I. If depth of next equals -1, then depth of next equals depth of cur plus 1. And then q dot push next, and then cout even depth dot size end line for I then depth, or actually we can just do c of even depth, then cout even depth of I, and then space, and then cout endl. And I'm hoping this should work. Okay, well, there we have an endless loop here. Sorry about any background noise, by the way. Oh, I forgot to pop. Okay, yeah, that would do it. Okay, pop it from the queue, and here we go. Try this. Oh, oops, I need to print next, or even this +1. So in the first, this works, and in the second, let's see, we put 1, 5, 2, and I'm looking at the diagram, that works also. Okay, cool, and Yeah, looks like everything's working as intended, so I'm just going to submit this for E and hope for the best. And let's just save this. Wrong answer on test 2. Oof, this is not going so hot. Problem is, that doesn't necessarily indicate that we have a really common error, because each case will have a lot of queries. Oh, actually, here's my issue. Yeah, it could be that the odd depth is smaller, so so we might have to do this if even depth dot size less than odd depth dot size. Else we do the exact same thing for odd depth. Yeah, because the problem is that the odd depth. I thought the even depth had to be smaller, but that's not necessarily true if the depth of the overall tree is even. So let's see. Now we get 3, 4, 6, which is still correct. So, oh, whoops! I just realized I didn't show what I'm doing. Here's my code. I basically just added this odd depth thing, and then we're gonna submit again. And then I'm pretty confident that this should pass. And now it's running on test 5, so that was the issue with test 2 anyway. It's taking a really long time to run on test 5. That's scary. Okay. I kind of want to look at D again. I'm worried that it's just multi-set being really slow, constant factor thing, which would really suck. Okay, accepted on E. That's good. Thank goodness. I'm just gonna read F real quick so I can start thinking about it. And turns each card we get cost and damage. Can't play more than 3 cost of okay, that looks interesting. Alright. Let's finish this first. Yeah, I'm kind of worried about this, because if multi-set is just being obnoxious, then I'm not really sure what to do about that. So this could take up to 200,000 times about 100, so 220 million, but that's fine. Still have to wonder if there's any way to get like an infinite loop. Like, what if let me just try like this. 1 and then 12, 6. Nope, got that nice and quick. Oh, am I recording? Sea lion? Yeah, I am. Good. Okay. Let's see. I mean, I've used multi-set successfully on other problems in the past, so it's not like that should be it's not like that should be the end of the world here. But maybe I'm wrong about that. And like hypothetically, if I am, I wonder what's the best way. To get around that. So I wonder if there's a better way to do this. Like, what if we say, yeah, I kind of want to just, recode this to rely a little less on multiset, perhaps. So we could start by, we could process everything largest to smallest to start, and we could try and decrease our reliance on multiset. So I'm gonna keep this file here, and then I'm just going to go ahead and yeah, I think I can implement a solution that doesn't rely on multiset, and I'm going to try that. So let's see. So I'm just going to throw out all this. I have it saved so we can get it back if we need it. And then we just have vector vi data, data.pushbackcur, and then okay, and then now into count rem of mx for I mx count rem of I equals 0. That's to count the ones that we need to remove. We'll increment it if we get a composite number that forces us to take out a smaller one. And then sort of all of data for decreasing I sc of data, and cur equals data of I. If cur is greater than 200,000, and I'm just going to make sure one more time that I have mx right. Yeah, I do. Okay. Then this has to be a large prime, so I'm just going to have a count large equals 0, count large plus plus, else if is prime cur. If we have a large prime, then this cancels it out, so we just do count large minus minus, and otherwise and I guess, yeah, so this could be with a I guess, yeah, actually the problem with sorting them all largest to smallest is what do we do with I guess actually no, if we have this is just for unmatched prime, or if we have unmatched primes. Yeah, because if we have an unmatched prime, then it's going to be paired with another unmatched prime. But the problem is, yeah, okay, let me think about this. So I guess we could just make an array of unmatched primes, and then we can process those largest to smallest. Let's just do that for the time being. So either in these cases, unmatched dot pushback cur, unmatched dot pushback cur. If it's composite, then and we can just copy this part from here. Res, all right, so yeah, so once we have, and then, oh wait, actually, hold on. First we should say if, else if, yeah, this could be a matched prime actually, so. So let's see, okay, I think this, wait, where does the 4 end? Else. Okay, so if we need one of these, then count rem of curve minus minus. That's the only thing we do. Okay, this is a bit of a mess. And stop pushback of curve. I still have ants defined, right? I don't think so. Okay. Oh yeah, I have it defined down here. All right, so ants dot pushback cur count plus plus. Okay, so hopefully that gets us a correct way to deal with the composites, and now we can just do something pretty similar actually with the unmatched primes. So first I'm just gonna reverse all of unmatched. For sc of unmatched, and cur equals theta of I if cur is less than 200,000 and we need one of the curs, then count rem of cur minus minus, else if cur is less than 200,000, then what do we do here? Then if cur minus 1 is less than size of large primes, then that actually might have been an error with our original ones, but count rem of and stop pushback cur, count rem of large primes of cur minus 1 plus plus. And I think that should do it. Let's test it. Okay, this gets 422. Okay, let's debug this. Oof, this problem took me way too long. Okay, let's see. Alright, so we start by processing the 5. That should go to the unmatched primes. And indeed, that's what happened. So now we have the 4. We should add the 4 to the answer, and then add and then we need a 2 now. So indeed, that's what happened. And let me make sure the count rem got incremented. Yes. Okay. So now we get to the 3. Another unmatched prime, and indeed went there. And now the other 3, also an unmatched prime. Cool. And then the first 2, that should just go towards decrementing that, and then the last 2. Okay, so the issue is down here with how we're dealing with the unmatched primes. So let's take a look at this. Alright, so first of all we have the here's the problem. I need to do unmatched of I. That gets 423, that's good. Get the 1999 thing. And we got 6. Alright. If this does not pass, then we are in big trouble. Back to test 8. Feels like it's running faster than before. And now we're wrong answer on 10. That's not good. Okay. Well, test case 10 TLE the old answer, and now it wrong at W8 this one, so that's interesting. Not sure what to make of that. So let's go through this. I'm just gonna make sure that this gets me a oh, whoops, I just tried to run it using the code as my input. That's not good. Alright, so let's see. So I'm just quickly making sure this gets us a correct list of primes. Yeah, looks good to me. Alright, so let's see. Primes, and then large primes goes up high enough, right?
So that's why it would be nice if we could.
I'm gonna assume it does. Okay, let's see. If, alright, in this case, yeah, it has to be in. If we already have a match, then we should just do that. If it's prime and it hasn't been matched yet, then it's an unmatched prime. And if it's composite, then into res, we figure out the smallest prime. Primes is sorted.
Right.
Yeah, it is. Figure out the smallest prime it's divisible by, and then the result, and then we set its result, and we move on. Okay, and then we reverse unmatched. Cur equals unmatched phi if cur is not a really large prime, but it has been matched already. Then yeah, okay.
But I'm happy to drive too.
If cur is less than.
Yeah.
Okay, I have no idea what's going on here, honestly.
It's insane. It was really crazy. Oh, I didn't realize we were
Shoot.
out of napkins. Okay, well, okay, bye.
Okay, let's see. I'm just gonna try some random test cases. Oh, whoops, sorry, this should be a 2. I don't think checking if it's I don't think the greater than 0 is going to make a difference, but just to be on the safe side. I could always try and assert to see if the size of answer is equal to n, because then if we get runtime error, then we would know that that's the issue, but I'm not sure what good knowing whether that's the case or not would do me. Oh, hey, a bug. Yay. That actually was not sarcastic, by the way. We're a lot better, yeah, we're a lot better off actually knowing where the bug is than not. Or actually having, like, once we actually have a test case, we're basically done debugging. So, that is unironically good news. So, I guess first let's process everything. And then we should have the 3. Okay, what happened to the 3? So we should have the. Oh wait, oh never mind. This is just a malformed test case. Darn. Oof. Okay. Well, I'm gonna try a similar case that's actually legitimate and make sure that it gives me the right answer. 7th prime is 17, I believe. Yep, okay. Okay. I have to wonder if something weird is going on with like the limits, perhaps. Like if, I wonder if it'll pass if I put MX up to 200,000, 200,100. I'm just gonna make sure that this didn't actually screw anything up, particularly on this case. Okay, I'm just gonna submit. I don't think that this is going to pass, but I kind of want to just see it. I'm also actually going to go ahead and throw in and assert the size of ants, that the size of answer is equal to n. I'm just going to make sure that this doesn't screw it up on an early case, but that way if the issue is that we're adding too many or too few elements to the answer, then our verdict will switch to runtime error. Okay, we got runtime error on test 10. So evidently that was the issue. Evidently, like we can see that the size of the answer is wrong. Kind of tempted to just take the 10-minute penalty hit and just now assert size of ants less than or equal to n, so that we can tell whether it's too high or too low our answer. But that is somewhat helpful information. count remainder occur greater than 0, then so let's see. So I'm just gonna check to think about how whether we're getting the right amount. We should be
Right.
yeah, because for everything we get up in here, we get we add 1 to count remainder and then get down here. And it better actually be in here, because if it's composite, then yeah. Okay, so
Older now, and
this should work. I wonder whether somehow we're having a situation where res is not equal, where for some reason cur is. Oh wait! Oh my goodness! I think I might know what's up. Yeah, I think I might have used I twice. Oh my goodness! If this actually is the issue, and that's how I screwed up my penalty, that would be no fun. Shoot. Okay. Alright, well, let's check. And no, that wasn't it. Okay. Yeah, I'm just gonna stick that assert in there because obviously if we have a composite number that isn't divisible by any of our small primes, we should be sending up the alarms because that should not be happening. You know, actually, I wonder if it would be more efficient to just say. And actually here, this is a good thing to check. I'm gonna make sure that our list of large primes is correct. Just gonna plug in some random test data, and then oh, it doesn't store, bugger doesn't store the size, so let me just do size of large primes end line, and then I just want to see like how many large primes there are, and then compare it with a oh. Okay, well that was informative. Okay, I forgot to check whether it was prime before pushing it into large primes. Okay, well, I sure am glad I decided to check that. I would have never figured that one out otherwise. All right, and actually, I'm just going to assert that. Actually, I'm just going to comment out the asserts. I'm pretty sure this is the issue, and I'd rather not get a weird runtime error because I did my asserts wrong. It's taken an awfully long time on test 1. Oh, I remember to, yeah, I deleted the print statement. Okay, yeah, test 5. Now we're stalling again. I'm gonna read F again. Okay, I think this passes. Oh my goodness, we lost so much time on that. Okay, yeah, and accepted. All right. Okay, so finally we can look at F now. All right. Let's see. Oh wait, yeah, this is just easy DP, Mac DP of Yeah, this is just easy DP. DP of number of turns by number of by the number of cards we've played mod 10. And so and then the possible transitions are we can play three cost 1s, a cost 1 and a cost 2, a cost 1 and a we can play up to 3. Yeah, okay, yeah, this is just easy DP. Alright, so alright, and then actually we should be doing LLs here. Gotta be careful about int versus LL and lowercase variable names because I'm not a monster. For I10 DP of 0 I equals negative, what's the minimum? I guess we could get up to about 10 to the 14, so I'm just going to say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, okay. DP of 0. 0, though, is just equal to 0. Alright, so for IN and K, C into K, and then let's do, so let's see, so then let's do alright, so let's store the cards. VI cards of 3, 4, IK, into num damage, into num damage, cards num -1 dot pushback damage, and then sort all of, and then all of cards of I, and then reverse all of cards of I because we want the highest ones first. And then let's see. So we have a few possibilities. We have 1, 1, 1, 1, 1, 1. We have 2 and 2, 1, and we have 3. So I guess, yeah, well, so let's do, oh, and actually I'm just going to do VL, not VI, and just to avoid having overflow issues. Best of 0 equals -1, best of 1 equals -1, best of 2 equals -1. Alright, and then I guess let's just do casework on all of these. So if the 1m and if this is greater than 3, best of 2 equals best of max best of 2, cards 0, 1 plus, or 0 plus cards 0, 1 plus cards 0, 2. If 2 best of 1 equals max best of 1 cards 0, 0 plus cards 0, 1. If cards 0 greater than or equal to 1, best of 0 equals max best of 0, cards of 0, 0. If SC cards of 1 greater than or equal to 1 and this, best of 2 equals max best of 2, cards of 1, 0 plus cards of 0, 0. If SC of cards of 1 greater than or equal to 1, best of 1 equals max best of 1, cards of 1 of 0, and then finally if S of cards of 2 greater than or equal to 1, best of 2 equals max best of 2 cards of 2 of 0. Alright, cool. Oh, actually, we may need to process all these cases separately rather than just doing best. Because, yeah, we actually need to process all these cases separately. This is annoying, but because we might want to use a suboptimal case with a smaller value of best, but that helps us double our damage. Alright, so let's just do for... Oh, and I better do J here, not... I don't want to make the same mistake as last time. Alright, so for J of 10. Alright. So LL damage equals this. LL best equals max. And then if J plus actually here, let's just do like this. If J plus 3 greater than or equal to 10, then damage plus equal this. And then actually here I should just do okay, and then dp of I plus 1 J equals, or J plus 3 mod 10 equals max of this and dp of I and J. Alright, cool. So now we can do the same thing over and over again. And then if J, yeah, I don't know if there's a nicer way to do this than this bash, but to be honest, I'm kind of inclined to just let it go. To just say okay. Oh wait, hold on, I need to do plus damage here, don't I? Okay. Man, I actually would have gotten a pretty good time had I not spent all that time screwing around on D, but oh well. Okay, let's see. Almost finished. So close. Okay, damage equals this. If J plus 2 greater than or equal to 10, we're doing basically the same thing we did before. This is not a particularly interesting problem to actually code. I do think I am happy with how quickly I came up with the DP idea though, because that was reasonably good time, I think. I am worried that I'm gonna make one tiny error with this case bash, and that's going to be a hot mess to debug. But oh well, we'll cross that bridge when we come to it. One problem at a time. And then we can basically do the same thing here. And then I think that's all of it. So now all we need to do is do like so. And oh, actually, I need to I need to account for the case where you don't play anything, because that's a valid option. dp of I plus 1j, dp of ij. Yeah. Good catch. Okay. Ants equals max of ants, and p of n I, and I just realized I should make I go up to 10. C out less than, it goes to ants, and then endl. And okay, I'm hoping this should be the end of it. Oh, well. Oh, I think oh yeah, math. I'm not sure why. I thought that might be an issue, but the syntax highlighting didn't catch it, so I thought it would be fine, but guess not. Okay, T63, thank goodness. And then I'm just gonna Control F to make sure I didn't overuse int anywhere. Okay, that's fine. Alright, good. Okay, now we just cross our fingers and we should hopefully be done. I think it actually would have been faster to just write this entirely than to debug the. Let's refresh, and hopefully when we refresh, it'll pop to accepted. Well, test 8, that's good enough. Hopefully it keeps going. 13. What's the time limit on this? 2 seconds. Well, 200,000 times 60 should be. Yeah, that's yeah, that should run just in time. Might be a little marginal, but I think we're okay. Yes, okay. Accepted. Alright. Okay, well, I can't say I'm super happy with this one just because of D. I think everything else I feel very good about. I think we made good time. It's just D, but anyway, let's see where we are on the standings. Oof, yeah. Yeah, that was, yeah, let's see. And if D hadn't been an issue, then, wow, yeah, we spent, I think I only spent, like, I guess I can check my status. Yeah, I spent about 10 minutes getting E, so if I had, so D ended up taking me a total of about 50 minutes, so it added, let's just say hypothetically, had I gotten it right on the first submission, that would have been 18 minutes. So I would, and just kind of trying to calculate what the penalty would have been had I not spent so much time sillying. Then my E time would be the same. My D time would have gone down by my D penalty would have gone down by 40 minutes plus the wrong answer, so it would have gone down by 80. And then my F took me 12 minutes to code, so F would have been 48, so it would have gone down 29. So it would have been a total of 109 lower penalty, which would have been 133, which would have been 9th. Yeah. Okay, so that would have been a bit of a jump, but yeah, that's why not sillying things is important. Anyway, hopefully this was somewhat helpful. I will try to do this again with the next few Division 3 and Division 2 rounds. I guess now there's not much more to do other than hope I don't mess up on system tests. Alright, so I'm going to end the recording now.